All right, we're going to try our first practice problem. We're going to kind of do this one together. Get this worksheet out, the one that says graphing practice. And the practice problem that we're going to start with is practice problem number 1. After I show you how to make a good graph this way, you'll be able to do practice problem number 2 on your own. So looking at practice problem number 1, we see that we have some data here, not a whole lot of other information. And it has to do with the pH of the water versus the number of tadpoles that are in the water. I need to identify the independent and dependent variable. So you might ask yourself this question. Does the pH of the water depend on how many tadpoles have survived in the water? Or does the number of tadpoles that survive depend on the pH? You might understand that pH is a chemical quality of water, and knowing this, you're likely to say, well, the number of tadpoles that survive depends on the pH, which means this is our dependent variable, and of course that's going to go on the y-axis, and then this is our independent variable, the thing that I am adjusting or changing, the scientist, and that's going to go on the x-axis. Now I want to think about how I'm going to scale this axis, either axis. So if I look at pH, it goes from about 5.5 to 8. That's not a big variation, but I know that pH, just because I happen to know a little bit about it, pHs are generally in the 0 to 14 range. So I'm thinking if I can, I'm going to make this axis go from about 0 to about 14. My other axis, the lowest value is 23, the highest value is 88. Whenever you scale an axis, you always want to have a little extra room if you can, because you might need to extrapolate data. I'm thinking maybe I should just make this axis go from 0 to 100. So now I have an idea of how I'm going to set up this graph. So I'm going to take a look here at my graphing paper. My graph paper is pretty big. Instead of making my graph take up the entire sheet of paper, I'm going to work in the top half of the paper. And I want to have enough room over in this margin to label my axes, and the same thing, enough room down at the bottom to label axes, and enough room sort of in the top or somewhere for a title. So what I'm thinking is this. I'm going to start about down here, about a little bit above the halfway point, and I'm going to come in 1, 2, 3, 4, say 5 blocks. That's going to be my starting point. Maybe I'll do this in pen so that you can see it a little bit better. So I'm going to go ahead and use a ruler to draw a nice straight axis here. You're using pencil. And then, of course, my x-axis is going to go like this. Now I need to scale off this axis, each of them. So remember what we said, pH is going to go from about 0 to 14. So when I look at this, I go, well, that's going to be like 7. But that's a lot more than 7 blocks. That's probably closer to 14 blocks. So what I can do is make each block worth a half. So let's see how this goes. If this is 0, that's a half, so this one would be 1. See, every other block is 1. So that's 1, that's 2, 3, 4. Notice I'm not labeling all the lines because that would just clutter my axis. A little tick at 5, a tick with the label at 6. Skipping every other one. You get the idea. I'm going to just extend this axis a little bit. Use your ruler. That should be fine. I'm going up to 12. Now, let's go ahead and label this axis. pH, lowercase p, uppercase h, of water. There's no unit for pH. My other axis is going to be the number of tadpoles that survive, and we said that should go from about 0 to 100. If I make each line 10, 10, 20, 30, 40, 50. It's going to go up to about there. I could probably do that. Let's see, what if I made each line 5? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. You know what? I'm going to, because I have room to go up to 90 here, so I'm going to extend this axis a little bit. So I can go up to 90. So remember what we did. Each block is worth 5. So something like this. 5, 10, 15, 20. Again, I don't want to clutter my axis, so I don't have to label every single line. 25, 30, 35, 40. 45, 50, 55, 60. 65, 70, 75, 80. And so this top line up here, this top tick mark would be 90. And that's going to give me enough room to squeeze my data in. Maybe it's not ideal, but it's not bad. I'm going to just turn my paper like this so I can label this axis over here. This is the number, I use the pound sign for that, of tadpoles that survive. That is the hardest part about making a graph. Making sure that you set up the scales on your axes properly and label your axes correctly. Notice, when you do a graph, the axes don't have to have the same scales on them. You can customize the scales on each axis. At this point, now all I need to do is to plot my data. So, at a pH of 8, I'm going to go up to 45 tadpoles. So I'm going to find that on here. At a pH of 8, I'm going to go up until I get to 45. So there's 40, and there's 45 right there. I'll make that with a nice black dot. All right. The next point is at 7.5. I have 69. So at 7.5, here's 7.5. It's one line to the left, and I'm going all the way up to 60, 65. This line would be 70, so just below that line would be 69. My next point, when the pH is 7, 78 survive. So there's 6, there's 7. So I come up the 7 line, and I'm going to go up till I get to 78. There's the 80 line. That's the 75 line, so about 3/5 of the way up that line would be 78. Next, at a pH of 6.5, I go up to 88. So here's 6.5. 88 is up here, right below my 90 line. At a pH of 6, 43. So there's 40, there's 45, 43 would be a little bit more than halfway. And finally, at a pH of 5.5, I'm at 23. So at 5.5, I go up to 23. 20, 25, 23 would be right in there. Now what I need to do is I need to put in a trend line. The trend line should summarize the data, show the relationship between these two variables. And I don't think that my relationship is going to look like this, a straight line. It's not saying that as the pH increases, the tadpole survival goes up. And it doesn't go that way either. So what I think we have in this case is just a pH at which the tadpole survival is the greatest, and anything higher than that and anything lower than that, the tadpole survival trails off. So my pattern is going to kind of be something like this. Goes up and then comes down. So I'm going to try to make what we call a best fit line that kind of summarizes that data. What I usually do is I usually take my pencil and I kind of sketch a line like an artist would sketch a line. So just kind of like this, real lightly, until I have something that visually looks really smooth to my eye with no really bumps or wiggles on it. And these points don't necessarily have to be right on the line because it's just a best fit line. It's just summarizing the pattern. Once I kind of have it sketched in, I can then darken it in. Perhaps I can use another color to darken it in. So let me use this blue pen. You can just use pencil if you want to. So I'm just tracing over what I've already done. To make it look nice and neat and smooth. Now my data stopped there and it stopped over there, so what I'm going to do is I'm going to just guess what it would look like, what that line would do beyond that range of known data. So I'm going to show this as a dashed line because I'm just guessing. But I don't know for sure where that goes. I can't have as much confidence. And now I have a pretty good looking graph. My axes are labeled, they're nice and neat, they're not too cluttered up with numbers. I'm only missing one thing. Have you figured out what I'm missing? I'm missing a title. So I could do something like tadpole survival versus pH of water, or I could do something like the effect of pH on tadpole survival. And I think that that's what I'm going to label it. I could, if I have room, just put it at the top of the graph, but in this case I have room in this area over here, in this area over there, so I can put my title there. The effect of pH is lowercase p, uppercase H. The effect of pH on tadpole survival. And there you go. That's a nice looking graph. So what are you going to do next? Well, for homework, you're going to continue working in space down here, or perhaps if you want on the back, you're going to do the same thing, but you're going to make a graph for your second practice problem. After you're done graphing this data, then you're going to answer these questions based on what you've plotted on your graph. Then you're also going to turn it over and you're going to draw best fit lines through each of these 6 graphs that are on the back. So for example, if I was doing a best fit line for this graph, I would take my ruler. This is why it's nice to use clear rulers. I would line it up so that my weighting of points above and below the ruler is about equal. And then I would draw in nice and neatly my best fit line, the line that summarizes the data. There I have a little outlier, otherwise it looks pretty good. Last thing, before going to practice problem number 2, make sure you understand what's going on here. Ethylene is a growth hormone, so you want to ask yourself, does the amount of growth hormone depend on the days it takes the apples to mature? Or do the days it takes to mature depend on the ethylene? That way you identify your dependent variable correctly. Remember, your dependent variable always goes on your y-axis. Your independent variable always goes on your x-axis. Good luck. Have fun with the assignment.